Welcome back, Math1720. We are rounding out Chapter 5 here. So this is Chapter 5, Section 6. We're going to go over the half angle identities and be able to apply them. Alright, so this is if we're going to get some funky angle that's like 22.5 degrees or something like that, how we can use those. And then, like we've been doing with all the sections, we're going to verify the identity. First few things here, I'm not going to go through all the derivations on this piece. If you want to copy the notes down, excuse me, that's entirely up to you, but I'm just going to get to where we're going to, get right into what the half angle identities are, and you're going to write those on your notes, and we'll kind of go from there. But just so you know, we can derive all the half angle identities from cosine, all right, if we want to start with this one, okay? And like I said, I'm not going to go through all of this, but I want you to understand kind of where it comes from and where the half angle identities come from. But I'm not going to go through all the proof on this one. I just want you to be able to actually apply the half angle identities. So you can see where we get the half angle for sine and cosine comes from, and then we can get all the versions of tangent. So what you need to write down, okay, are these half angle identities. These should be the ones that are on your trig sheet. Alright, that you've been keeping track of, that has all the Pythagorean, the double angles, the sum and difference identities, your long list of growing identities that you've been using here. Okay, so with that, you can see all of these. I'm not going to read all of them off, but you can see that there's one for cosine, one for sine, and there's 3 different ones for tangent, all just kind of based on the form that we get. So however you want to organize those in your notes, that's the best way to kind of go about it. Okay, just remember the plus or minus, that's always going to be relative to what quadrant the solution lies in. You're still using, all students take calculus, so that sine is positive in the second quadrant, tangent is positive in the third quadrant, and cosine is positive in the fourth quadrant. So you really just, that's where the, it comes into, where do you choose? Do you choose the negative answer or the positive answer? It's just based on where the quadrant is, or what quadrant we end up in. All right, so let's go ahead and get into this. Let's do an example here. Okay, we want to find the exact value of cosine of 15 degrees using the half angle identity for cosine, right? Because normally I can't give you a nice triangle for cosine of 15 degrees, all right? There's not a nice 15, 75, 90 trig ratio that you guys can use in this, okay? So what I want you to be able to do is, hey, can I work backwards a little bit, all right? So if I use the cosine of half angle, what I really want to do is double that given angle, okay? So if I can double my 15, what does that give me? That gives me 30. That's an angle that I know and I can work with. Okay, so I want you to think about that. So I can rewrite 15 as 30 over 2. That helps me use the half angle identity for cosine when I do this. So when you get these weird numbers like on your test or things like that, all right, think about, oh, maybe if I just double this number, it'll make sense, all right? So just think about how we can go about doing that. So let's think about rewriting cosine of 15 degrees as cosine of 1/2 times 30. Now, okay, that's going to give us the half angle identity. All right, so the 30 represents our a. So remember, it's cosine of a over 2. So 30 is our a here. And since we are doing 15 degrees, we are located in the first quadrant, so we have to choose the positive root. Remember, 30 degrees is a nice triangle that I can work with. We have a 30, 60, 90 triangle, or we have a 1 square root of 32 triangle. So you're able to find the exact value of cosine of 30 when we do this. Remember, we're choosing positive because we're in the first quadrant. All right, just to reiterate that piece here. And we know that cosine of 30 ends up being the square root of 3 over 2. This is where we have to, do our due diligence and be able to do the algebra piece as we go through this. If you're not getting the algebra, let me know. We'll go over some of the basic fraction stuff in class when we do this, but essentially we have 1 plus the square root of 3 over 2 all over 2. So I'm going to multiply that numerator by 1/2, okay? So I'm going to get 1/2 plus square root of 3 over square root of 4. Then I'm going to find a common denominator of 4. Alright, so I got to multiply that by 1/2 by 2 over 2. So I'm going to get 2 plus square root of 3 over square root of 4. Then I can take the square root of 4. That gets me that 2 in the denominator. So I'm left with the square root of 2 plus the square root of 3 all over 4 when I simplify that down. So I kind of walked you through the algebra. I'm not going to show you the steps. I do expect you to be able to do that. In class, we'll go over the board, so if some of you guys want to watch the live stream of this, if we have it going on, you'll be able to kind of see the algebra behind that piece. All right, let's find the next one. All right, we want to find the exact value of tangent of 22.5 using the identity tangent of a over 2 equals sine of a over 1 plus cosine of a. All right, so what do I want you to think of here? We have tangent of 22.5. You need to get it into the half angle formula, right? So what do I want you to do? I want you to double that. So what should a really be? A should be 22.5 times 2, which happens to be 45. Now that makes it really easy. All right, we substitute 45 in for a. So that's the first step with all these half angle identities. Take the angle I give you and double it when we're applying the half angle identity, and that's really the angle in question. So we can take 22.5 times it by 2, we get 45. So we're going to apply this tangent of a over 2 equals sine of a over 1 plus cosine of a. Now it's very simple. We substitute 45 degrees in for a. Okay. Now that gives us, we should all know what sine of 45 is, because remember 45 is a 1 square root of 2 triangle. Okay. Same with cosine. So we should get both of those. All right. So sine should be what? 1 over the square root of 2. Cosine should be 1 over square root of 2. Then we have to rationalize that denominator. All right, and simplify things down. So when we get this, sine of sine of 45, all right, is 1 over square root of 2, and then we rationalize the denominator, so we get square root of 2 over 2. And this cosine of 45 will be the same thing. It'll also be square root of 2 over 2. So we're going to get square root of 2 all over 2 divided by 1 plus square root of 2 over 2. Then we have to find a common denominator on the bottom if you want to and work through that and then multiply by the reciprocal. Or we can multiply through by what's going to clear the denominator. So I can also multiply in the form of 1 as 2 over 2. So I'm going to multiply the numerator by 2 and the denominator by 2. So when I do that, I'm left with the square root of 2 divided by 2 plus the square root of 2. Now, remember to simplify that, because we cannot leave the radical in the denominator, we have to multiply by the conjugate. Okay, remember doing that in an earlier lecture. All right, the conjugate is where we take the same expression, we'll use the opposite sign. So since in the denominator we have 2 plus the square root of 2, we're going to multiply the numerator and the denominator by the conjugate over the conjugate. So it's going to be 2 minus square root of 2, because we're multiplying by 1. 1 is in the form of 2 minus square root of 2 over 2 minus square root of 2. And remember, 2 minus the square root of 2 is the conjugate of 2 plus square root of 2. We do that to eliminate the radical, all right, because when that FOILs out, the radical terms are going to disappear. So when we simplify this down, the square root of 2 on top has to distribute to the 2 and the square root of 2. All right, and then on the bottom, we're going to be left with 4 minus 2. So we get left with 2 square roots of 2 minus 2 divided by 4 minus 2. All right, and out of the top, we can factor a 2 out. We always want to see what's the best way to simplify things. If I factor a 2 out of the numerator, all right, I'm left with 2 times the square root of 2 minus 1 all over 2. Well, the 2 over 2 now cancels to 1, and I am left with the square root of 2 minus 1 as my solution. So the trig piece on this is relatively easy. Okay, that's the easy part. It's getting through the algebra and simplifying the expression down. I think where a lot of you guys are going to maybe struggle on this. So pause this video, rework this example, and see if you can do it on your own and be successful. If you can handle something like this, this one's not necessarily super easy, but it's not necessarily super hard, but it's a good foundation. So if you can rework this example, on your own and get the right answer, it will really help as a good source of practice for you. Okay, so we want to find, okay, the actual S now going the other direction. Okay, so now I'm not giving you the angle, I'm giving you the ratio, limiting it to a specific quadrant. Okay, so before, right, I gave you, what was it, like cosine of 15, the last one was tangent of 22.5. You had the angle in that one and you had to find the ratio. Now we have the ratio and we have to find the angle, so we got to work backwards. In this case, we're going to find cosine of s over 2, sine of s over 2, and tangent of s over 2. If you want to relate that back to your trig identity sheet, s is equal to the a that's written on your trig identity sheet. Now, we do have a restriction here. We have a restriction that s, the angle s in question, has to be between 3 pi over 2 and 2 pi. That means all of our angles, or all of our solutions, have to apply to the fourth quadrant. Okay, remember, cosine is the only one that's positive in the fourth quadrant. So our sine and our tangent need to end up being negative for this, but we want to find s. Okay, so let's go about that. Remember, we're given cosine of s is equal to 2/3. So we already know that the hypotenuse of the triangle is 3, all right, the adjacent leg is 2, and then we have some other value you can use with the Pythagorean theorem to find, right? You can take 3 squared minus 2 squared, all right, so you're going to get 9 minus 4. We know the other value is the square root of 5, and it has to be negative because of the quadrant that we're in. All right, so s over 2 lies in the second quadrant here, all right, with, that's not right on my notes at all, all right. Oh, sorry, yes, I misspoke there. S lies in the fourth quadrant. S over 2 cuts that in half, that lies in the second quadrant, okay, because it's half of what's in the fourth quadrant. So that's kind of helpful with how you're doing that, okay. So that's where that translation goes to. So that is correct as we go over this. So sine, we're going to relate everything to the second quadrant with the half piece, okay? So sine of s over 2 is positive in the second quadrant, while cosine and tangent are going to be negative in the second quadrant, okay? The s angle is what's in quadrant 4, so that's what you have to understand. The s over 2 angle is what's in quadrant 2. So this one may get a little confusing on that, but re-go through this, see if that helps a little bit. So let's apply what we've got here. We want to take sine of s over 2. Okay, we're doing this one first because it's the positive one, is equal to 1 minus cosine of s divided by 2. Well, we know what cosine of s is. It's given to us, all right, as 2/3 in the problem. So I'm going to write sine of s over 2 is equal to 1 minus 2/3, okay, over 2. You're going to simplify that down, all right, so you're going to rationalize the denominator, and when you work through all the algebra, we're going to get square root of 6 over 6. So the half angle, sine of s over 2, is equal to square root of 6 over 6. Now, cosine of s over 2, we're going to get minus the square root of 1 plus cosine of s over 2. That's just your trig identity. All right, we're going to substitute in, okay, because we know what cosine of s is. It's still 2/3. And notice, you just need to be able to work through the algebra piece here. And then we have tangent of s over 2. We can use it as sine over cosine, right? Remember, that's a basic identity for tangent, sine over cosine. Why do we do it that way? Because we already know what sine of s over 2 is, and we already know what cosine of s over 2 is. So we don't want to have to pick one of the other tangent ones that's more involved. This is the least involved one, okay? So it makes your algebra simpler. So we take the value we got for sine of s over 2, which is square root of 6 over 6, divided by negative square root of 30 over 6. Okay, we multiply by the reciprocal. All right, so we end up getting, the 6's will cancel, so we get negative square root of 6 over square root of 30. We have to rationalize the denominator, right? So we're going to multiply the numerator and the denominator by square root of 30 over square root of 30. All right, and we end up getting negative square root of 180 divided by 30. And you can simplify that down even more if you break down the square 180. Okay, remember 180 is going to be a nice number that you can break down. That'll break into square root of 36 times 5. Square root of 36 is 6. All right, so that breaks down, and then 6 goes into the 30 5 times, so we get negative square root of 5 over 5 for our tangent of s over 2. Okay. All right, moving on to the next part, we want to simplify each expression. All right, notice they're very, very similar to our half-angle identities, right? Only we have 1 plus cosine of 12x, all divided by 2, and there's a plus or minus in front. All right, so this does match the identity for cosine of a over 2. We just have to identify what a actually is when we go through this. So we're going to substitute 12x in for a. That's really what happened there, okay? So when we do that, all right, we get plus or minus the square root of 1 plus 12x over 2. That's what we started with, right? We can rewrite that as cosine of 12x over 2. That's a over 2. So we're just simplifying the left-hand side of your identity with this, okay? So that's really what we're doing. So we have cosine of 12x over 2, because 12x is our a, and then 12 divided by 2 is 6, so we're left with cosine of 6x, okay? Let's look at the next one, okay? That relates to our tangent, okay? Our tangent identity. So if you're looking over at your trig identity sheet, a is equal to 5 alpha, okay, on your trig identity sheet. So that one just simplifies down to tangent of 5 alpha over 2. Okay, lastly, we want to verify that an identity. So this is, remember, where we choose the most complicated piece, all right, and make it look like the other side. All right, so first off, we want to verify that sine of, you can say a over 2 if you want, plus cosine of a over 2. That way it simplifies and matches your trig identity sheet, but that's okay. We have sine of x over 2 plus cosine of x over 2 quantity squared. We want to prove that it equals the identity of 1 plus sine of x, okay? So this is where we're going to work with the most complicated side first. So the most complicated side is the sine of x over 2 plus cosine of x over 2 quantity squared. What you need to do is FOIL that out first, or use the box method. It's a binomial being squared. So you got to do first, outside, inside, last, or however you remember to do that, okay? Or write that as the two binomials next to each other. Do your box method. But when you multiply this out, all right, remember when you're squaring something, you're timesing it by itself, you end up getting sine squared of x over 2 plus 2 sine of x over 2 times cosine of x over 2 plus cosine squared of x over 2. All right, so now we have multiplied all of that out. And we should always look for, hey, is there something in here that we can simplify real quick? All right, so what I like to always look for is look for your Pythagorean identity. We have a sine squared of x over 2 plus a cosine squared of x over 2. All right, so we can separate that out. There's no factoring or anything going on. It's just rewriting what we did. Okay, so we have sine squared of x over 2 plus cosine squared of x over 2 plus 2 sine of x over 2 cosine of x over 2. Okay, so that first part goes to 1. It's just the Pythagorean identity. Remember, the sine squared of x plus cosine squared of x is equal to 1. It doesn't matter if it's sine squared of x over 2 plus cosine squared of x over 2. It's still sine squared plus cosine squared of the Pythagorean identity. That entire first chunk rewrites to 1. Okay? Then we have our other identity. I can rewrite 2 sine of x over 2 cosine of x over 2. If you look on your trig identity sheet, you should see like 2 sine a cosine a. Okay, that's really what you're looking for. It's a double angle identity. So you can rewrite 2 sine a cosine a as sine of 2 times a. Okay, so think about that as you go through. So we're rewriting that double angle. So essentially, the 2 times 2, okay, cancels out, becomes 1. So we are left with 1 plus sine of x. These are problems that you're going to really have to work through, all right? And give them some time, step back when you have to approach a problem like this. The verifying the identity is going to probably take you the most time on your homework. But this is why it's important to have the identity sheet next to you so that you can see, oh, hey, I can rewrite this as this. All right, and it will really, really, really help you out. So please, as you're doing your assignment, have your identity sheet on one side so that you can look back and forth and be able to relate a much more simplified version of what you might have on your paper. So, you know, our third line up here, it looks really complicated. We got sine squared of x over 2 plus cosine squared of x over 2 plus 2 sine of x over 2 cosine of x over 2. Right? That looks complicated. But that sine squared, cosine squared, always look for the Pythagorean identity and killing something down to a 1. Okay? Makes it very, very easy to simplify there. And then look at your other identities. Can I rewrite that as a double angle? Absolutely. All right? So you just need to step back. You might have to work the problem 2 or 3 times, and that's okay. But eventually, you know, practice, practice, practice. You guys will get better at these. All right, well, that's the end of Chapter 5. Let me know, like I said, if you have any questions or ask some questions in class. We'll do some more examples on the board if you need to. Else, guys, have a great day.